Hello my dear students and friends, this is Dr. Ami Khan, and in today's video I am going to solve some question from equilibrium. Without wasting any time, let us start. The first question is KSP, which is the solubility product of sodium chloride, is 36 m square per liter square. The solubility of sodium chloride is. So to solve this question, we must know that sodium chloride is an electrolyte which produces two ions. So for two ions producing electrolytes, the relation between KSP and S is this. So this KSP is given as 36, so is equal to S square. This implies S is equal to under root of 36. So the answer is 6. So the right answer for the first question is C. Okay, let us move to the second question. The second question is degree of dissociation of ammonium hydroxide in water is 1.8 into 10 power minus 5. Then hydrolysis constant of ammonium hydroxide. Okay, so for this we need to know the relation between KH, which is the hydrolysis constant for ammonium chloride salt, which produces ammonium hydroxide and HCl. Okay, the relation between KH and KB is KW divided by KB. KW is the ionic product of water, which is 10 to the power minus 14, and KB is given in the question 1.8 into 10 to the power minus 6. Sorry, this is 5. So when I divide this 1 by 1.5, this comes out to be 0.55 into 10 to the power, this is minus 9. Okay, so this is 5 into 10 to the power minus 10. Okay, so this is the hydrolysis constant of ammonium chloride. So the answer is D. Okay, now let us move to the third question. The third question is what volume of 1 molar sodium formate should be added to 50 ml of 0.05 molar formic acid to produce a buffer solution of pH 4. pK of formic acid is 3.8. So this is a good question but somewhat lengthy. Okay, let me move like this. Okay, now to solve this question, the relation between pH or the formula to calculate pH for acidic buffer is pKa plus log of salt concentration divided by acid concentration. Okay, so this pK is given as 3.8 and the pH is given as 4. So we need to calculate this S by A. So concentration of salt can be obtained with this formula. Concentration, which is molarity, this is equal to millimoles divided by volume, total volume. Okay, so for this salt, let me write salt concentration like this. Millimole of salt will be, this is the salt, sodium formate, and its molarity is given. Millimole is molarity into volume. Okay, so this is 1 molar, which is 1 into sodium formate, that V is to be calculated. What volume of 1 molar sodium formate solution should be added? Okay, so this V is the volume of sodium formate, and divided by total volume is this V plus, now 50 ml of what formic acid is added, so 50. So this is the molarity of the salt or concentration of the salt. Okay, and concentration of the acid is likewise we can calculate concentration of acid is equal to volume in ml into molarity, that is 50 into 0.05. This comes out to be 2.5. Okay, 2.5 divided by V plus 50. Okay, so after putting these two values here, which is equal to, let me write here, pH is given as 4 is equal to pK is 3.8 plus log of salt is this one, V divided by V plus 50, and the concentration of acid is in the denominator, so I can write like this. This is the concentration of the of the acid, so this is V plus 50 divided by its millimole is 2.5. so this V plus 50 and this V plus 50 is cancelled out, and this is equal to 4 is equal to 3.8 plus log of, this is V by 2.8, right? V by 2.8, and now this can be written as 4 minus 3.8 is 0.2, which is equal to log of V divided by, what is this, 2 point, this is 2.5. okay, V by 2.5. okay, let me rough this one. So to calculate antilog of V upon 2.5, I can write like this. Let me rough this one, okay, because I need space. That was equal to 0.2 is equal to log of V divided by 2.5. okay, so V divided by 2.5 is equal to antilog of, means 10 to the power 0.2. This is the antilog of 0.2, and the antilog of 0.2 comes out to be 1.5 approximately. okay, so when I multiply this 1.5 by 2.5, this comes out to be 3.96. so 3.962. okay, so 3.962 ml is the correct answer, but here the correct option is not given here. okay, so this has to be 3.926 3.962 ml. Okay, now let us move to the third question. The third question is the fourth question. An acid Ha ionizes S like this. Okay, this is the ionization reaction of the acid, and the pH of 1 molar solution is of this acid, pH is given as 5. Its dissociation constant would be, so we need to calculate dissociation constant of the acid. This is a weak acid. okay, so dissociation constant of 5. So from pH I can calculate H plus ion concentration. okay, H plus ion concentration, pH is 5, so H plus ion concentration is 10 to the power minus 5 molar. So 10 to the power 10 power 5 molar H plus ion concentration, and this is the concentration of H plus ion. What would be the concentration of A minus ion? And this is, I think, this is also the expression of Ka. I can write like this: Ka is equal to H plus ion concentration into what? A minus ion concentration. okay, so H plus ion concentration is 10 to the power minus 5. so since these two H plus and A minus ion concentration have same molarity, so this A minus ion concentration will also be 10 to the power minus 5. So the answer is 10 to the power minus 10. So the correct option is A. Okay, next question. Okay, this is the question. Phosphorus pentachloride dissociates as follows. This is the reaction. If total pressure at equilibrium of the reaction mixture is P and degree of dissociation of PCl5 is X, this is the equilibrium pressure, X is the what? Degree of dissociation. then the question is partial pressure of PeCl3. Okay, so for this question, let me write like this. This PeCl5 initially has, suppose, 1 mole. Okay, then PeCl3 will have 0 mole, 0 mole, like this. Okay, now at equilibrium, suppose some x mole of PeCl5 has been dissociated, so we will get PeCl3 concentration at the equilibrium, that will be x. Similarly for Cl2, this will be x, right? So partial pressure of PeCl3, this is PeCl5, this is PeCl3, and this is for Cl2. Okay, so partial pressure of PeCl3 is number of moles of PeCl3 divided by total moles. In fact, this is the mole fraction of PeCl3 multiplied by total pressure, and this number of moles of PeCl3 is x, and total pressure is this will give total mole, this will be equal to 1 plus x. So x by 1 plus x multiplied by P. This is the expression for the partial pressure of the gas PeCl3 at equilibrium. So the correct answer is, I think, A. Okay, the correct answer of 5 is A, x by x plus 5. Let me show you. Okay, this is x by x plus 1, P. Okay, this is the correct answer. Okay, let us move to the next question. The next question is for gaseous phase reaction. This enthalpy change is given as minus 43.5 kilocalorie per mole. Which statement is correct for this reaction? Remember, this reaction is the reverse of this reaction. Okay, so this reaction has to be endothermic, because for the given reaction enthalpy change is minus, so for this reaction enthalpy change has to be plus 43.5. okay, so this is an endothermic reaction. So for endothermic reaction, K increases, when temperature increases, for endothermic reaction, when temperature increases, equilibrium constant value also increases. For if temperature decreases, K also decreases. This is for endothermic reaction. So the correct option for this question is K is independent of temperature. That is wrong, because K depends on temperature. Okay, and second one is K increases as temperature decreases. This is also wrong. K decreases as temperature decreases. This is the correct option for the sixth question. Okay, the seventh question is, let us move to the seventh question, which would decreases the pH of what 25 centimeter cube of 0.01 molar solution of ICl. Okay, the addition of magnesium metal. The first one is addition of magnesium metal. This will not affect the pH of ICl solution. Okay, second one is the addition of 25 centimeter cube 0.02 molar ICl solution. So when ICl is dissociated, this will produce H plus and the Cl minus ion. So, and we know that pH is equal to minus of log of H plus ion concentration. So increasing concentration will decrease pH. So the question is which would decrease the pH of which would decrease the pH of which would decrease the pH of 25 centimeter cube of 25 centimeter cube means 25 ml of 0.01 molar solution of ICl solution. Okay, so addition of ICl to an ICl solution will increase the concentration of H plus ion. So this will decrease the pH Okay, but the question is, this is also ICL solution. Okay, this is also ICL solution. So this is just like, we are adding two ICL solution, ICL plus ICL. Okay, so this is 25 ml and 0.01, and for this let me write 25 into 0.02. So in the second option, 25 into 0.01 plus 25 into 0.02 divided by total volume will be 50. Okay, and in the second option, this is the concentration of the ICL to be added, and this is lesser than 0.02. So more is the increase in the concentration of H plus ion, lesser will be the means decrease in the pH value. So adding higher concentration of ICL will increase pH to a large extent. So the correct option has to be B, because in this option concentration of H plus ion is 0.02, and while in the third option this will also decrease, but to large extent the decrease will be by this option. So the correct option for the seventh question is B. Okay, let us move to the next question, which is not a Lewis acid. Which is not a Lewis acid among these options? CCl4, SnCl2, AlCl3, BF3. Lewis acid is that acid which is electron deficient. So SnCl2, AlCl3, BF3, they are electron deficient, so they are Lewis acid. But CCl4 is neither electron deficient nor electron excess, so this is not a Lewis acid. Okay, so let us move to the next question, which is Lewis base. Which is a Lewis base? HCl is not a Lewis base. HNO3 acid, HF acid, NH3 has lone pair of electron on nitrogen, so NH3 is the correct option. Okay, now let us move to the next question, which is solubility product constant KSP of salts AX, MX, MX2, M3X at temperature T are 4 into 10 power minus 8, 3.2 into 10 power minus 14, and 2.7 into 10 power minus 15 respectively for these salts. So the question is solubilities mole per decimeter cube of these salts at temperature T are in order. Okay, so for this question we need to solve solubility from KSP. For MX, the relation between KSP and the S is KSP is equal to S square. So for MX KSP, the value of KSP is given as 4 into 10 power minus 8. This is given as 4 into 10 to the power minus 8. So S will come out to be 2 into 10 to the power minus 4 after taking out the square root. Okay, so we will get the value of solubility for this salt MX as 2 into 10 power minus 4. So for MX S is 2 into 10 to the power minus 4. Okay, for MX2, the relation between KSP and the S, KSP is equal to 4S cube. So after putting KSP 3.2 into 10 to the power minus 14. SK value comes out to be 2 into 10 to the power minus 5. So this is 2 into 10 power minus 4, this is 2 into 10 power minus 5, this is larger, okay. And for M3X, which produces 4 ions, the relation between KSP and S is 27 S to the power 4. Yes, and after putting the value of KSP, which is 2.7 into 10 power minus 15, S comes out to be 1 into 10 to the power minus 4 mole per liter. So S is maximum for MX, this one. Then in the second order we have this value, and the third one is this value. So the correct option is first MX, then M3X, then MX2. So the correct option is D. Okay, in this way we must solve solubility. Okay, now let us move to the next question, which is for this system 3A plus 2B gives C the expression for equilibrium constant. This is very easy question. I think this is the correct option. Okay, no need to solve. Let us move to the next question. A monoprotic acid 0.11 molar solution ionizes to 0.001%. Its ionization constant is. So for such acid, this is value of alpha or X. Alpha is 0.001%, means this is 0.001 divided by 100, and this comes out to be 10 to the power minus 5. Okay, this is the value of alpha. So we need to calculate the value of ionization constant for the monoprotic acid. So the expression for ionization constant Ka is I think I can use this relation, C alpha square, after neglecting the value of alpha in comparison to this is the expression. Actually this alpha is neglected because the alpha value of alpha is very small in comparison to 1, so I can easily neglect this value. So I can just write C alpha square. So the value of C given in the question is 0. I think this is 1. Okay, this is 10 to alpha value is 10 to the power minus 5, that is square, and the value of C is 0.1. 0.1 is 10 to the power minus 1. So this is 10 to the power minus 10, 10 to the power minus 11, I think. So the correct option is A. Now let us move to the next question. Okay, the next question is for the reaction C solid and the carbon dioxide produces 2 mole of carbon monoxide. This is partial. Okay, partial pressure of carbon dioxide and carbon monoxide are 2 and 4 respectively at equilibrium. KSP for the reaction is Kp. Okay, now the expression for Kp for this particular equilibrium reaction will be partial pressure of carbon monoxide to the power 2 divided by partial pressure of carbon dioxide. Since this is solid, we will not include in the expression of Kp. So partial pressure of carbon monoxide is given as, I think, 4. So 4 is square divided by carbon dioxide has a partial pressure of 2, so this is 2. So this is 8. So the correct option is C. Okay, now let us move to the next question, which is 14. The precipitation is noticed when an aqueous solution of ICl is added to an aqueous solution of. So when this ICl is added to NaNO3, we will get NaCl, which is dissolved in water, which is soluble in water, so no precipitation will occur. When ICl is added to barium nitrate, again barium chloride will be formed, and then that barium chloride is water soluble, no PPT will be formed. Again zinc sulfate plus ICl, zinc chloride will be formed, and zinc chloride is also soluble in water. So the correct option has to be D. When ICl is added to IgNO3, we will get Ig, this is ICl, okay, so we will get Ig2Cl2. This is not soluble in water, so we will get PPT for this salt, okay. So the correct option is mercuric nitrate. Okay, now let us move to the next question, which is magnesium is, oh wait, okay, now magnesium, oh where are you, here, okay, magnesium 2 plus is then Al3 plus. So these are Lewis acid. So magnesium 2 plus has plus 2 charge, aluminium has 3 plus charge, so this will attract electron more easily. So this is a stronger Lewis acid than magnesium 2 plus ion, which has lesser positive charge. So magnesium 2 plus is a weak Lewis acid than aluminium 3 plus ion, weaker. This has to be, the term has to be weaker, okay. So magnesium 2 plus ion is weaker acid, Lewis acid than LCl3. So the correct option is C. Okay, let us move to the next question, which is the equilibrium constant for the reaction, this reaction N2 gas plus O2 gas gives twice NO gas, is 4 into 10 power minus 4 at 2000 Kelvin. In presence of a catalyst, the equilibrium is attained 10 times faster. Therefore, the equilibrium constant is in presence of the catalyst at 2000 Kelvin is. So here the question to be arised is, does equilibrium constant depend upon catalyst? The answer is no. The value of equilibrium constant depends only upon temperature. So here temperature remains constant, so equilibrium constant does not change. So the equilibrium constant value has to be this one only, that is 4 into 10 power minus 4. B is the correct option. Okay. Let us move to the next question, 17. The activation energies for forward and backward reaction for this are 180 kilojoule per mole and 200 kilojoule per mole. This is for the forward and this is for the backward respectively. The presence of a catalyst lowers the activation energy of both forward and backward reactions by 100 kilojoule per mole. The enthalpy change for the reaction in presence of catalyst will be, okay, the enthalpy change for the first reaction without the catalyst, enthalpy change is calculated by this formula: activation energy of the forward reaction minus activation energy of the backward reaction. This is activation energy of the backward reaction. So the first for the reaction without the catalyst, activation energy of the forward reaction is given as 180, and for the backward reaction this is 200. So I will write 180 minus, this is enthalpy change, okay, this is 200 and this comes out to be minus 20. Okay, this is the enthalpy change for the reaction, and this shows that this is an exothermic reaction, but enthalpy change does not change with the addition of catalyst. So the enthalpy change has to be this value only, minus 20. Okay, so this is the correct option 17. The correct option for 17th question is A, minus 20. Okay, now let us move to the next question. How will increase pressure, how will increase of pressure effect on equation? This is an equation, and for this equation, delta ng value has to is delta ng is, I think, 2 plus 2 minus 1, 2 minus 1, this is plus 1. Okay, so increasing pressure increases the concentration of the product side to a larger extent. So when the increase in concentration in the product side is more than the increase in concentration in the reactant side, according to Lee-Chatter's principle, the reaction will move backwards. So the correct option has to be B. Okay, yes, B is the correct option, shift in the reverse direction. Okay, now let us move to the next question, which is this one. The pressure of N2H2 mixture in a closed apparatus is 100 atm, and 20% of the mixture then reacts. The pressure at the same temperature will be. Okay, now let me write the reaction. This is N2 plus H2 gives NH3, and if we balance this reaction, this is 2 and this is 3. So here we must keep in mind that the number of moles of the reactant is 4 and the number of moles formed in the product side is 2. So half difference of 2 is there. From 4 moles of ammonia we will get only 2 moles of, from 4 moles of nitrogen and hydrogen mixture we get only 2 moles of ammonia. Okay, so in the question it says that for 100% the pressure is 100. Okay, so 20% of the mixture is converted into ammonia. 20% of the reaction mixture has been converted into ammonia. Okay, so hydrogen nitrogen mixture left is 80%, right? Because 20% has been converted into ammonia. From that 20%, ammonia formed will be only 10%, because from 4 moles of nitrogen hydrogen mixture only 2 moles of ammonia is produced. So from 20% of the hydrogen nitrogen mixture only 10% of ammonia will be formed. So hydrogen nitrogen percentage left is, this is left. Okay, and ammonia formed is 10%. This is formed. Okay, so the pressure, the final pressure has to be for this percentage, that is 90%. Okay, so for 100% the pressure is 100 atm, so for 90% the pressure has to be 90 atm. Okay, so 90 atm is the answer. This is the answer B. For the 19th question the answer is B. Okay, 20. Question number 20. Sodium acetate XS in ethanol. We know that this is a conjugate base of this ethanol, which is a very weak acid. So for weak acid, the conjugate base, this is C2O minus, is very, very strong. So this is strong base. The answer is strong base. Okay. 21. A solution of sodium borate has pH of approximately sodium borate. This is a basic salt. So the pH is greater than 7. Sorry. Okay, let us move to the next question. 22. A certain buffer solution contains equal concentration of X and the HX. Ka of HX is 10 to the minus 8. pH of the buffer solution is. Now this is a buffer solution. This is X minus and HX is the weak acid. Okay, so this is an acidic buffer. Ka is also given. Okay, so expression for pH of acidic buffer is pH is equal to pKa plus log of salt concentration divided by acid concentration. So it is said in the question that this X minus is concentration of salt and the HX is acid. They have same concentration, so these two cancel out. We have this pKa plus log 1 and we know that log 1 is 0. So pH is equal to pKa and pK is minus log of Ka and K is 10 to the power minus 8 is given in the question. Okay, so pH has to be 8, so the correct option is B. Okay, B is the correct option. Let us move to the next question. Okay, next question is study the following table. Buffer solution. These are the buffer solutions obtained by mixing this weak acid and its base, sodium salt of weak acid. Okay, and these are the volume in ml 4 and molarity of the acid is 1. So we must take out millimole for this question. Okay, millimole is important here. So the question being asked is, let me move slightly forward. Okay, now which of the two sets of buffer solutions will have least pH? Okay, so we must know the relation of pH for acidic buffer, that is pKa. So pKa will be constant for the weak acid. This is plus log of salt की concentration divided by acid की concentration. Okay, so now pH will be less when concentration of acid is greater than concentration of salt. Okay, concentration of acid is less than concentration of salt, then only this will give a negative value, and pKa minus negative value will give a lesser pH. So we need to choose the two buffer solutions having less pH from these 4 buffer solutions. So we need to calculate for concentration. We must know how to calculate concentration. Molarity concentration is millimole divided by volume of solution, like this, millimole. Okay, now here just calculate the total volume will be same. Okay, so we just compare the millimoles of acid and base. Millimole is 4 into 1, this is 4 into 1. These are all millimoles of the acid, but for the salt, millimole is this is 4 is multiplied by 0.1 and this will give 0.4. okay, this is the value of millimole of the salt. So here we must choose that option in which acid has more concentration than salt, right? So here acid has more concentration than salt. This is okay. In the second question, in the second buffer solution, millimole of the acid is 4 and millimole of the salt is 40 into 0.1, that is 4. So 4 and 4, these are equal. Okay, these are equal, so this cannot be the fraction of the option. Okay, the third one 40, and this is for 4 into 0.1 is 0.04. okay, so this 40 is greater than 0.04, so this will have least, in fact, pH. This the third buffer solution will have the least pH. So in the fourth buffer solution, 0.1, 10 into 0.1 is again 0.1. So these second and the fourth are in the second and fourth buffer solution, we have same concentrations of the acid and salt. So the correct option has to be 1 and the 3. So 1 and the 3, B is the correct option. Okay, let us solve 25 question for this video. Let me move to the next question. 24th, which indicator works in the pH range of where is the question, wait, which indicator works in the pH range of what, 8 to 9.8. so answer is phenolphthalein. This works in basic medium. Methyl orange and methyl red works in acidic medium. So pH range is has to be lesser than 7, and litmus works in the range of 5 to 8 pH value. So this can be both acidic or basic. Okay, but phenolphthalein is works in the range of basic pH, that is greater than 7. So this is the option. Okay, next question is 25 ml of 0.01 molar HCl solution is mixed with 100 ml of 0.005 molar HCl. The pH of the resultant solution is. Okay, for solving this question, we must know the expression, which is okay, concentration of H plus, this is both are acid. Okay, this M1 V1 plus M2 V2 divided by V1 plus V2. So M1 is 0.0015 into 100 plus M2 is 0.005 into 100. Okay, into 100. Now divided by total volume is, I think, 200. Okay, this will give the concentration of H plus ion. So after solving this, I get this. Okay, wait, I get this is 10 to the power minus 2. So this is the H plus ion concentration. So pH, this is the H plus ion concentration. So therefore we get pH of the solution as 2. So the correct option is C. 25 has the correct option C. Okay, there are many questions, but for this video let me complete here, and in the next video I am going to solve remaining questions. Okay, let me complete here. If you like this video, please share this video to your friends. Okay, thank you.